Okay, in this second half of the blood video, we're going to take a look at blood grouping and transfusions. Now, there's even a country song that talks about we all bleed red. Very true. But, after mixed success of trying to give anybody's blood with any other human, because it's all blood, it's all red, that we should be able to mix, they found out that not always was that the case. There's more often than not, individuals were starting to have blood starting to clot up and people started to die due to adverse reactions. So they started taking a look at what's the issue. Why are people starting to die when they're giving blood? And blood is blood, right? Well, taking a little bit closer look, we find out that there's actually some indications that is actually on the red blood cell surface called antigens, or the scientific term agglutinogens. And in our bloodstream, we talked about our white blood cells' job is to create these guys, antibodies, for anything that is foreign or recognized. For example, antigen is something that was foreign that's on the red blood cell surface. We have antibodies to recognize against it, or agglutins. These are the scientific terms for antibodies. Now, if they match up, meaning the antigens and antibodies match up, you start to see a clumping together of the red blood cells, and that clumping together is known as a clot or agglutination. Now, agglutination is due to the interaction of the proteins on the red blood cell surface, antigens, with a certain antibody carried in the plasma. I'm going to do an illustration or a drawing here in a little bit that I hope will kind of walk us our way through the combinations of blood typing. But for this video, I'm just going to kind of walk through the written portions of it and then go back into the drawing aspect of it. Now, only a few of the antigens on the red blood cell surface produce transfusion reactions, and those ones that we typically think of and we've talked about in multiple allele inheritance or codominance are ABO blood grouping. These include, so our A dominant, B dominant, actually we should have this little as a little O because O is recessive group. And then the RH factor. RH factor is seen a little bit. It's named after the rhesus monkey. It is a factor that if you have this antigen present, you are considered a positive blood group, or if you do not have it, it's lacking, you would be considered negative. So like example, A positive blood or A negative blood. Okay. So in our ABO blood grouping, now we need to be able to get our particular antigens and antibodies squared around. We never want them to match, meaning if I have an A blood group, I don't want to have A antigen and A antibody. A's and A's would stick together, so I need to have the opposite. So I have a type A blood. The one recognizes as a type A blood is what's on the red blood cell itself, that being the antigen. So I have antigen A on the blood cell, but in the plasma I've got the one that does not match against it, which would be antibody B. These antibody B's would stick to if somebody with B blood would give it to me. Now, a type B blood person has B antigen B's on the blood cell itself, but have the opposite in antibodies, so they have antibody A. So a B blood type person cannot give blood to A, and an A could not give blood to B because of the antibodies that they have in their bloodstream that are present. One quick other note is that when you donate your blood, you're actually not donating your antibodies. You donate your blood cell itself. So you can't get rid of the proteins. You can't get rid of the antigens. So even though if I can get rid of all of these A's when I donate, you are still donating that antigen to this person, and they have, in the individual person, they have antibodies against you. So B blood cannot donate to A because they have these antibodies B that are going to stick to the B antigen. If I look at type AB, they have both A and B antigens, but they don't have any antibodies against. All right, so that tells you that there's nothing that will stick, so they can be the universal acceptor. Type O blood has no antigen on the red blood cell surface, so you can think of it like an actual O. There's nothing actually sticking out here. And so there's no protein on there that gives it an antigen, but the thing that's unfortunate about them is that they have both antibodies. So A blood or B blood cannot be donated to them because they have antibodies that would stick, which means that they can give out their blood because nothing can stick to their blood, but they can only receive blood from O. So we just mentioned earlier, an adverse transfusion is things where you're going to get materials with A mixing with A antibody when we don't want that. We don't want B's matching up with B's. We don't want AB's matching up with an AB. We don't want that because if that's going to happen, again, it's not cool. It's going to cause agglutination or clotting to occur. So in an artistic illustration, you're going to see here is our A blood type. Has antigen A, so that's why we represent A blood type. I don't want A antibody, so I got to have the opposite. These two will not stick together like a nice puzzle piece. However, if I go, and I'll show you in the next slide, if antibody A, if you can take a look at this point, that point would fit perfect with this A here, which would start it to clot. I don't want that to occur. So that's why we need the opposites. Antigen B is on our B blood cell that has antibody A. Type AB has both antigen but no antibodies, and type O has no antigens but both antibodies. Alright, so here's what would happen. Normal, not normal, clotting, agglutination. Here, you see of antigen A, so this is blood type A, antibody B. That's what we want. But for some reason, we donated A blood to a person that has B blood type because they had antibodies in their blood type. So when I donated this blood, all of a sudden you start to see these antigens stick. They stick together like a puzzle piece. And as they stick together, that causes this clotting factor to occur. Okay? Now, we could take this one step further. What we've been talking about is A, B, AB, and O. 4 main blood types. But there's actually, you consider 8, because you can bring in this RH factor. The RH factor was named again after the rhesus monkey. If that RH factor protein is present, you are considered to be positive, which the majority of the population in the US, approximately 85%, are RH positive. So a person with RH positive blood can receive blood from somebody, but if you are an RH negative person, that means you are going to have antibodies against RH. So if we go all the way back up to A blood type, if we're looking at type A blood type has A antigen, B antibody. If they're A positive blood, they're going to have A antigen as well as RH antigen and antibody B. If they're A negative, they're only going to have A antigen, but they're going to have 2 antibodies. They're going to have antibody B and antibody RH. Okay, and hopefully the illustration here in a little bit will help that out. All right, so take a look at that. Now, in the event that you are a negative blood type, you can donate blood to a negative as well as a positive person. But if you are of a positive blood type, you cannot donate to a negative because, again, those individuals that have negative blood type have the antibody against the RH factor. So the true universal donor is actually O negative because they can donate to A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, and O negative. Where the O positive person can only donate to O positive, AB positive, B positive, and A positive. Alright, there are no corresponding antibodies in the plasma unless the person is going to have this. Okay, RH negative blood is transfused with RH positive, which means that at the very beginning in development, a person typically does not have it, so they're going to develop this adverse reaction later on. And a really, really scary thing that we have to be aware of, especially females need to be aware of, is of a disease known as erythroblastosis fetalis. It's a disease in which you will, as a mother, will reject the fetus during their second pregnancy because the mom during the first pregnancy developed antibodies against the RH factor, and so when that baby came along, that second baby came along, the mom sent out antibodies to attack the baby, which eventually leads into, again, a fatal disease or fatal thing that's going to occur to the fetus. Okay, we can reverse that. We can stop that from happening by using this injection known as ROGAM. All right, here's just an artist's illustration of that. So if mom is negative, dad's positive blood type. Okay, during the first pregnancy, baby's positive blood type, but they share blood. And being that they share blood, some of the positive antigen in the blood starts to develop into mom. Now this is foreign. So mom is saying, whoa, what's going on here? I need to develop these antibodies against it. Now I've got all these antibodies. During second pregnancy, here's second baby, all of a sudden mom's saying, I'm not going to have that happen. I'm going to attack the fetus and lead into an abrupt abortion. All right. Last slide here is just taking a look at some of the who can donate to who and who can receive blood from who. We'll see this later on, but you're going to have questions like, can A negative blood give blood to AB negative, or can A positive blood give to AB negative? And the way you can take a look at that is that, all right, here's A positive blood. A positive blood should be able to give blood to who? And in looking at it, this is who they can give blood to if I look down. A positive can give blood to A positive. A positive can give blood to AB positive. Okay, those are the ones that they can give blood to. Who can they receive blood from? A positive can receive blood from A positive. They can receive blood from A negative. They can receive blood from O positive. They can receive blood from O negative. Okay, so that's again how you read that. And our last slide just kind of takes a look at the differences of blood types. We said universal donor really should be O negative, and our true universal recipient or acceptor is going to be AB positive because they receive all blood types. AB negative cannot receive any positive blood types. So AB positive is the true universal acceptor. O negative is the true universal donor. And then we look at our averages in the states. This is a few years old, so it's still probably fairly correct, but according to the population standards, that again 85% of the population is going to have that Rh positive factor. AB is looking like a rare of the blood type. In particular, AB negative would probably be one of the most rare blood types. And then you get into the B negative, pretty rare, all the way through. But O positive in particular looks like it's probably the most prevalent in the U.S. All right. Well, that concludes the second half of the blood transfusion and blood grouping. Again, go ahead and take a look at the next video. It's going to be on the illustrations of how blood can donate, who can donate to who based upon antigens and antibodies.